All right, today we're going to tackle something that is absolutely fundamental in Swift, the big difference between value and reference types. And trust me, once you really get this, it's a total game changer for writing cleaner, safer, and just better code.
So, let me just start by asking you this. In Swift, when you write a line of code to copy something, from one variable to another, are you really getting a fresh copy, a true independent duplicate? Or is something a little sneakier happening under the hood?
Well, the answer is, it totally depends. And look, this isn't just some academic trivia. Understanding this distinction is absolutely critical because it directly impacts the safety, the performance, and frankly, the predictability of your code. This is the stuff that makes or breaks your apps.
So, let's get into it. Let's call this our tale of two copies and really break down the two different ways Swift thinks about and handles your data.
First up, we've got value types. And honestly, the best way to think about these, just picture a good old-fashioned photocopier.
So what do we mean by value semantics? It's simple, really. It means that anytime you assign a value type to a new variable or pass it into a function, Swift just makes a brand new, totally independent copy of it. That's it. Each one is its own unique thing.
And this is where that photocopier idea really clicks, right? Imagine you photocopy a document. Then you take a big red marker and scribble all over that copy. What happens to the original? Absolutely nothing. It's still safe, untouched, back in the filing cabinet. That's the exact same principle at play here.
Okay, let's see this in a bit of code. We've got a simple struct here called point. We make an instance of it, p1, and set its x value to 9. Now, here's the magic moment. We say var p2 equals p1. Because a struct is a value type, Swift basically hits the big photocopy button. p2 is now a completely separate copy. So when we change p2.x to 10, we're only drawing on the photocopy.
And the result? If we check the original p1.x, it's still 9. See? It's completely unaffected. This is what we mean by safety and predictability. There are no weird, spooky side effects. What you see is what you get.
So to wrap this part up, with value types, and we're talking about things like structs and enums, every single variable gets its own private, independent piece of data. And that just makes your code so much easier to think about, and way, way less likely to have those nasty bugs that seem to pop up out of nowhere.
Okay, so that's one side of the coin. Now let's talk about the other, reference types. And for this one, I want you to completely forget about the photocopier. Instead, I want you to think about sharing a link to an online document.
You see, with reference semantics, when you make that assignment, you are not getting a new copy of the data. Instead, you're just getting a new pointer. Think of it like another label or another shortcut that points back to the one and only original piece of data living in memory.
And that shared link analogy is perfect. If I send you a link to a Google Doc, we don't each have our own copy, right? We're both looking at and typing in the exact same document. If you change a word, I see it instantly on my screen, and vice versa. That's exactly how reference types work.
Let's jump back to the code. Same setup, but this time our point is a class, and classes are reference types. So we create p1, x is 9. And now the crucial line. Let p2 equal p1. Remember, no photocopy this time. All we've done is create a second label p2 that's aimed at the exact same object as p1. So when we then change p2.x to 10, well, if we go back and check p1.x, boom, it's 10 now too. Why? Because p1 and p2 are just two different names for the exact same object. You change it through one link, and it's changed for everyone because they're all sharing that one piece of data.
And that right there, this idea of multiple variables all pointing to one single instance, that's the whole point of reference types. It's incredibly powerful when you intentionally want a single shared source of truth that different parts of your app can all interact with. Okay, so we've got these two very different, very powerful tools in our toolbox. The big question for you, the developer, is how do you know which one to pick? When do you choose one over the other?
Well, here's a pretty good rule of thumb. You're going to want to reach for value types, your structs, most of the time. Use them whenever you want those safe, independent copies and predictable behavior. They're perfect for modeling data. On the other hand, you should reach for reference types, your classes, when you have a specific need for a shared state, or you need features that only classes have, like inheritance.
Let's just zoom out for a second, because this whole conversation, it's not just a technical detail.
It really gets to the core philosophy of the Swift language itself.
This table right here is basically your cheat sheet. On one side, you've got value semantics, your structs and enums. They get copied, they're super safe, and they're your go-to for data models. On the other side, reference semantics, your classes. They're shared, you have to be more careful, and therefore when you truly need a single shared object.
And this brings us to the big takeaway, the guiding principle straight from the people who made Swift. The official advice is this: prefer value types. You should start with a struct, only move to a class when you have a very clear and specific reason to. This values-first mindset is really a cornerstone of what makes Swift feel so safe and modern.
So there you have it, the tale of two copies. You now have the framework to make a conscious, informed decision every time. The next time you're building something new, just ask yourself that simple question. Do I need a safe, independent photocopy, or do I need a shared, collaborative link? Getting that answer right is going to make all the difference.